Hey guys, you are watching Simple Civil with Smriti Gupta, that is me. In this video, we'll be solving this question by moment distribution method, and this question has already come in an exam. So in this question, we have this B support. This B support is an intermediate joint. Intermediate joint are semi-fixed joints. Semi-fixed joint behave as one because two members are attached to this joint, so it will behave as one. There is no relative translation in that joint. Two members, they get attached to that support, will behave as one. So in this question, either this support will go up or down together. There is no relative translation. So this is your B support, which is your semi-fixed or intermediate. Let's go on step number 1. So step number 1 is your fixed end moment. Fixed end moment, FEM, we can write in the short manner. So in this question, how many members we are having? We have AB, BA, then your BC and CB. Now how we decide that what moment sign we should take? So this is your bending moment curve, this is your fixed joint. This and these are the moments which is trying to fix the beam to the normal. So this is giving a anti-clockwise rotation, that is positive, and this is your clockwise, that is negative. So we are taking positive, negative are sign conventions. So I am writing it on the beam only so that chances of confusion or mistakes are less. So here I am writing it. The formula what we are using is, because this load 40 kilonewton is not symmetrical, so we'll be using this formula, and for UDL we have WL square by 12. Just substituting the values of the loading and the distance what is given in the formula, we'll get our desired fixed end moments. So do not forget to write the units, that is kilonewton meter. Always we have to write the units wherever we are writing fixed end moments, as well as in intermediate in between the questions. So this is your kilonewton meter. So similarly for BC member also, we'll be just substituting the values of load and the length of the beam, and we'll be writing our answers. So here we are, this is your 20.83 kilonewton because it is a symmetrical loading. So both the moments are same. Next we have step number 2. Step number 2 we have RF and DF, that is your rotational factor and your distribution factor. What RF and DF has role in our moment distribution method and in our beam? So this B is the common support. This left side and right side moment on B has to be equal and opposite. So this DF and RF, these are the factors which decide how much load has to be transferred to which member. So according to the EI of the members, in this question EI is constant. So according to the EI of the member, this factor will decide which member will take what fraction of moment. To calculate this, we have to make one table. So that table will have joint, member, then your RF sum and your DF. So we'll be making this table. So in this way we'll be making the table. So I am just putting a line here, thoda tedha ho gaya hai, please do not mind that. So the joint we are having, you can see on the photo, the joint we are having is B. The connecting members are BA, BC, then RF. How to write the RF? How to decide what is your RF? So for that, if fixed joints are there, so this is a fixed joint, we'll be writing 4EI by L. And if one is fixed and one is your pin joint or roller joint, so we'll be writing 3EI by L, that is your modified RF or rotational factor. So we'll be using this formulas for finding out the RF in this question. So we'll be just substituting, since your BA is fixed, so we'll be writing 4EI by L, and your BC is your pin joint or your roller joint, so we'll be using 3EI by L. Now if EI is twice, thrice, accordingly we'll be writing. In this question, since EI is constant, I am just substituting the value of L. L is 6. So I'll be writing that. I'll be 5 in BC member, so I'll be writing that. The sum is 19 by 15, or in decimals we can write it as 1 point this much. So what is your DF? DF is your RF divided by your sum. So this will come out to be this much. Always remember, the sum of all the DF coming at a joint has to be equal to 1. In this question, it was coming out to be 473, but I make it 474 to adjust it to 1. Now, this table is your step number 3, final step, that is your moment distribution table. So, in this table, what we have to do? We have to make the table in the same manner what our beam is look like. So, first is your ABC, then I have written your RF and DF. So, you can see your BA and BC is having these values. I have written that, and your A is your fixed support, you can see that, and your C is your pin joint or a roller support, and these are the fixed end moments. So I'll be writing these fixed end moments in the table, you can see that. So these are the fixed end moments I have written, and this is your joints. So your A is fixed, C is your simply supported. Now I'm just drawing it so that you can always remember it, or you can keep your question in front of you. That is also very easy. So now in this question, C is your simple support. Simple support, no moments came. It is always 0. So what we are doing, equal and opposite, we are putting a moment here so that this is 0. Half of it will be carried to adjoining joint. So this is your fixed support. So half will be transferred to your adjoining joint. Now I am putting a line. What you have to do at B support, you have to sum up all the moments. So if you will sum up the total minus 17 and this, if you will sum up in your calculators, the amount you are getting is this much, 13.475. This one we should not write it on the table. It has to be in your calculator. Just for your simplicity I am writing, and this is a positive. So what we will be doing, we are putting a negative sign here because whatever additional moments are coming, we have to neutralize it with the opposite sign. So I am writing it and multiplying it with the DF, and I am writing the final moments. So just minus this multiplied by this, and you will be getting the final answer. So this is a pin joint, nothing will be going to a pin joint. This is your DF, this is your FEM, this one is your carryover, this one is your balancing moment, and the next one will also come out to be as a carryover. So in this question, these moments came, nothing will go to the pin joint. Half with the sign moment will come to the A joint, because this is a fixed end. Fixed end moments, it will only receive, it will not give back anything. So this one and this one, this is your carryover. Now I am putting a line, and now I'll be summing up all the moments. We have to just sum up all the moments. So summing these two will be getting positive 32.006. Now summing these two will be getting negative 24.858. Summing all this, we are getting a 24.8. So this has to be equal and opposite. So this is negative, this is positive, just equal and opposite moments are coming. So now we are at the final step of making the bending moment diagram. What we have done is, we have just simply make the beam, and then I am just drawing. So I am putting a dot line under the load and under the support. So this is your 40, which is not symmetrical. We'll be using the formula, and so this is the ordinate what we are getting. This is a simply support bending moment what we are drawing here. Simply support bending moment at this point, and we'll be just drawing the moments which we got after the moment distribution method. So this one is your 32. I am just writing 32 here. Then this one at the B support, we are having this is as 24. So I am just drawing it, and always remember all the ordinates in the beam, we have to make it On side means positive we have to make, upside of the beam. And this one is 0, so I am putting a 0 here and I am simply joining it with the simple hands. So here we are. I am just joining my bending moment diagram with the free hands. Just join it and shade the alternate portions what you receive. So these are the critical points and these are the critical zones where these two graphs cut each other are the critical zone. So this is the final answer. If you like my video, please give me a thumbs up. Please subscribe to my channel for more videos. Thank you for watching.